The James Webb Space Telescope is the most powerful and largest space telescope ever constructed. It will allow scientists to examine the state of our cosmos 200 million years after the Big Bang. The telescope will catch images of a few of the oldest galaxies ever formed. It will also be able to peer into clouds of dust to see where young stars and planets are forming, as well as study the environments of planets orbited. But can it discover the new galaxies? Does the James Webb Space Telescope create a new revolution in the study of this universe? Is it capable of capturing high-definition images? How is it made? The James Webb Telescope is 3 stories tall and a tennis court long. It's so large that it must be folded and transformed to fit within the rocket. Once in orbit, the sunshield will be the first to unfold. The James Webb Space Telescope observes the universe in a kind of light that is imperceptible to human senses. Infrared radiation is the name for this type of light, and humans can feel it as heat. Infrared cameras are used by firefighters to see and save individuals through the smoke of a fire. The James Webb Space Telescope's infrared sensors will be used to peer through the dust in our universe. Inside those clouds of dust, stars and planets originate. Thus, peering inside could lead to some fascinating new discoveries. It will also be able to observe objects, such as the early galaxies, because it is so far away that their light has shifted from visible to infrared due to the expansion of the cosmos. The cameras of the Webb telescope are sensitive to temperature changes from the sun. Webb has a solar concentrator to protect its equipment and mirrors, like how you could wear a hat or visor to shield your eyes from the sun. The sun shield on the telescope is approximately the size of a tennis court. The temperature differential between the telescope's sun-facing and shaded side is over 600 degrees Fahrenheit. Mirrors capture and focus light from faraway stars, allowing space telescopes to see. More the specifics the telescopes can see, the larger the mirror. Launching a huge, massive mirror into orbit is quite challenging. Engineers responded by giving the Webb telescope 18 miniature reflectors that fit together as a jigsaw. Inside the launcher, the mirrors fold up, then unfold in orbit to form a single giant mirror. What's the significance of the gold mirrors? Infrared light is reflected by a tiny layer of gold on the mirrors. Planets don't just live in our solar system. Millions of planets orbiting stars apart from our sun have been identified by scientists. These are referred to as exoplanets. The James Webb Space Telescope will aid in the research of extraterrestrial atmospheres. JWST is primarily meant for near-infrared astronomy, although depending on the instrument, it can also view orange and red visible light. And the mid-infrared spectrum. It can detect objects up to 100 times fainter than Hubble, and things from considerably earlier in the universe's history, dating back to redshift Z20, about 180 million years cosmic time after the Big Bang. For context, the first stars are thought to have formed between Z30 and Z20. 100 to 180 million years galactic time. The first supernovae may have formed around redshift Z15, approximately 270 million years cosmic time, and Hubble is only able to view back to about Z11.1. Very early reionization, galaxy GN Z11, 400 million years cosmic time. With high-resolution infrared light photographs of 19 galaxies, NASA's James Webb Space Telescope will enable researchers finish a more detailed sketch of the star life cycle within the first year of operations. A few critical puzzle pieces that have been lacking until now will be provided by the telescope. Janice Lee, Gemini Observatory Chief Scientist at the National Science Foundation's NOAR Lab in Tucson, Arizona, remarked, JWST touches on so many distinct phases of the star life cycle, all in remarkable resolution. Webb will unveil planet formation at its early phases, exactly when gas compresses to become stars and warms the surrounding dust, says Webb Chevalier. NASA has released new photographs from the James Webb Space Telescope as it continues to test its sensors in preparation for science missions. And these stunning, crystal-clear photographs arrive on the heels of Webb's full alignment. According to a NASA blog post, the James Webb Telescope is starting to move forward with its next and last round of preparations, known as Science Instrument Commissioning. And like the assortment from last week, the test photographs that result from this are noteworthy. Webb's whole field of view is displayed when the telescope is aligned with all of his instruments, and it keeps improving. In a NASA blog post, Webb's optical telescope element manager Lee Feinberg of NASA's Goddard Space Flight Center said, "These extraordinary test photographs from a successfully aligned telescope illustrate what people across global regions can achieve when there is a bold scientific vision to explore the universe. The optical performance of the telescope is consistently exceeding the engineering team's expectations, with mirrors currently pouring cosmic light into a highly defined flash of light. into all of the instruments. All instruments' image quality is diffraction limited, which means that the sharpness of detail which can be seen is as excellent as practically possible in terms of the telescope's size, says the company. The principal mirror parts will continue to be adjusted on a regular basis in the next weeks and months. In the article, Webb's photon beam sensors and control scientist Scott Acton of Ball Aerospace wrote, "With the accomplishment of telescope synchronization and half a lifetime's worth of effort, my position on the James Webb Space Telescope program has come to an end. We've started working on the observatory's technical operations as NASA's James Webb Space Telescope nears completion of its science instruments commissioning. While traveling through space, the telescope will constantly locate faraway celestial bodies and point them with great precision to obtain photos and spectra. However, we intend to study the planets and their satellites, asteroids and comets in our planetary system as they move across the galaxy's background stars. Webb must be able to freeze onto certain objects and navigate them precisely enough to capture photos and spectra. The Webb team has finished the first test of tracking a moving object. The test confirmed Webb's capacity to operate moving target science. As we progress through commissioning, we'll test other objects traveling at different speeds to ensure that we can study objects moving all through the solar system with Webb. Webb will be able to see inside exoplanet atmospheres and witness some of the galaxies formed after the universe was created by using infrared light, which is undetectable to the naked eye. The photographs were captured when the huge golden mirror components of the telescope were successfully aligned. The test photographs demonstrate the observatory's 4 instruments' ability to capture clean, well-focused images. A comparison of photos taken of the same object by Webb's mid-infrared instrument and now the retired NASA's Hubble Space Telescope's infrared array camera produced the most stunning result. Webb's massive reflector and monitoring systems can pick up much more information than Spitzer and allow for more discoveries. Spitzer was the first space telescope to collect high-resolution photographs of the cosmos in close and mid-infrared light, and was previously part of NASA's Great Observatories program. Webb's image displays remarkable details of interstellar medium between the stars, according to scientists reviewing the 2 photographs of the cumulonimbus cloud, a small nearby galaxy of the larger Milky Way. During the press briefing, Klaus Pontoppidan, Webb program researcher at the Space Telescope Science Institute in Baltimore, revealed that the first photos of the universe, known as early release observations, or EROs, are planned to be released in mid-July. These first beautiful color photographs will demonstrate that Webb is functioning perfectly, marking the start of several years of science. Webb's precise targets for these first photographs haven't been released because the telescope crew doesn't want to give anything away. And as the crew gets closer to obtaining photographs, these goals may shift. In terms of aesthetic quality, the first photographs will be like what we've seen from the Hubble Space Telescope. A nebula is a region of high-density interstellar dust particles that is used to form stars. Massive torrents of dust particles envelop the newborn star, blocking most of the visible light they generate. Infrared from newborn stars fortunately penetrates the dust barrier. Strong infrared observatories, like as the James Webb Space Telescope, should be able to see them. The discovery of the Earth's origin and the evolution of life are 2 of JWST's main goals. Both are inextricably linked to planet evolution. One of the primary objectives is to determine the makeup of particles in the vicinity of stars where planets form. Infrared photos of planetary systems will be captured by hypersensitive observatories like the JWST. Want to keep up with NASA's largest and most powerful telescope and learn more about it? Will James Webb Space Telescope reveal the untold theories of space? Want to know more? Then subscribe to our channel and get notified about the updates. Looking forward to seeing you in the next one. Until then, peace.